All right, welcome back everyone. Today we are looking at 10.7, which is all about writing and graphing equations of a circle. So, in a coordinate plane. So, in order to graph and, well, write a circle, we first need to understand our circle equation. So, here we have, first we're going to be looking at the equation where a circle is centered at the origin. So again, the origin is the point 0, 0 on the coordinate plane. So where x is 0, y is 0, it's where the two axes meet. All right, so an equation of the circle looks as such. So we have x squared plus y squared is equal to r squared. Again, the x and the y, we do not put in numbers for those right now. In our equation, those are our variables. So they stay as x and they stay as y. The only thing that we're really plugging in here is our radius. So our radius is our r. So it's however long that radius is going to be. Which if you're given a graph, most times you will be able to count the radius. Again, depending on which direction you're going into. All right, so in order to understand our equation a little bit better, let's first write an equation of a circle that we have on here. So I know that the axis numbers are a little bit tiny, but each different thing is one unit. So what we need here is, well, we are centered at the origin. The center of our circle is right there. It's at the point 0, 0. So we will be using this formula up here. So we have our x squared plus y squared. And now we just need our radius squared. So our radius here, so I know that our picture up here shows the radius going diagonally like this, but that's really hard to count and um, impractical when it comes to this problem. So there are 4 different ways that we can count the radius. We can go from the center to the right, because here we have that it ends at point, this is 4, 0. So that means our radius, our length here is 4. The same if we go up instead. So if we go up, that's the point 0, 4. The distance here is also 4. We can go to the left. That is also 4, just in the direction of negative x. So we have negative 4, 0. Or we can go down, and that is also 4. And this is point 0, negative 4. So we can go in any one of these directions when we're centered at the origin. Just count how many units are across. We have our radius is 4 here. So we can plug in 4 for r. So we have r squared. So 4 squared. And then we can actually work that out. So we have 4 squared is 16. So this would be the equation of our circle that's pictured right here. So all this tells us is that it's centered at the origin. So that's going to be our center, and that it has a radius of 4, because we can square root 16 back to get 4. All right, but our circles aren't always going to be centered at the origin. So we have kind of an adjustment formula for that when we are dealing with circles that are not centered at the origin. So the only adjustment here is we have 2 new variables. We have h and we have k, which help us move our center in a different direction on our coordinate plane. So r squared stays the same. Our radius, part of our equation, is going to be the same. But here, now we have our center is at the point hk. So we have that h corresponds to the x value of our center and k corresponds to the y value of our center. So that makes sense when we look at our larger equation right here, is that we have the h part of our center is attached to the x of our equation, and we have that the k value is attached to the y because they each represent our center part of our equation up here. And so this also helps us with problems that are centered at the origin. So for example, we have the origin is 0, 0. So if we were to plug in our origin here, so we have x minus 0 squared plus y minus 0 squared is r squared. So in this sense, we have, well, if we subtract 0, it's still going to be x. And if we subtract 0, it's still going to be y. So this also works for centered at the origin. It just gives us that x squared plus y squared is equal to r squared. So it doesn't change at all. All right, so if we are dealing with a problem where we have a point on our circle, if we're not given the best radius measurement to count it, we can use the distance formula to find the radius. So it's basically where we have our radius. Again, we did learn this in Unit 1, is our difference of our y values squared plus the difference of our x values squared. So basically where our center is the value x1, y1, and the point on our circle is going to be x2, y2. So this can also help us find the radius as well. All right, so let's take a look at writing an equation given some information. So here, for example, we want to write the standard equation of a circle centered at -2, 3 with a radius of 2. All right, so let's write down our important information in terms of our variables. So when we're looking at our equation, we have 3 different variables. We have h, k, and r that we're going to be filling in. So let's see if we have any of that information in our actual problem. So here we have that the radius is 2, so that's given to us. So we have our variable r is 2. We're given our center, so our center is -2, 3. So that means that we also have our h and we have our k. So our h is our x value, so it's going to be -2, and we have k is our y value, which is 3. So now all we need to do is plug it into our equation from before. So I'm just going to quickly write that here. So we have y minus k squared is equal to r squared. Now we just need to plug in our 3 variables. So we have our h is first, so we have minus h, so we have minus a -2 squared plus our y minus k, so minus 3 squared is equal to r squared. So r is 2, so 2 squared. And now we can do a little bit of cleaning up here. So for example, we have our x minus -2. We can clean that up and we can make that x plus 2 instead. All right, and so that is squared. And we can leave our y minus 3 because we can't subtract 3 from our y. So that'll just be y minus 3 squared. And then we can have x squared. We can make an adjustment to that because x squared is actually 4. So here we have, this is our equation of our circle. So we're going to box that. All right, so you don't need to do anything with the x and y. Those can just stay the same because that's what makes the equation of our circle, is that x and that y are all the points that are on our circle. So in order to have the equation, we need to have them in there as just variables. All right, so next we're going to be taking a look at some graphing aspects. So I do have all of the directions off to the side here. So we have, first you want to plot the center of your circle. Then you want to determine the radius, so how long the radius is going to be. Then you can plot your 4 points. So your 4 points should be above, below, left, and right of your center. I'll show you what that looks like. And lastly, we want to just sketch the circle on the outside. So that's where those 4 points come in handy. You'll see in a second. All right, so first we want to plot our center. So we need to be able to identify our center when we're looking at an equation. So again, our center is the point HK. So in this specific example, if we take a look at our equation up here, we have our h is attached to the x. So we have, this is a +1. So this will be -1, because remember our formula is x minus h, not x plus h. So in order to get that plus in our equation, it would have to be a -1. Because like with this problem here, we had that x minus x2 right here, which then turned into a plus. So we had the -2 to begin with. So now we're just kind of working that backwards. All right, next we have our k value. Our k value is attached to our y. We have -3, so that means our k value is 3. All right, so we have our point is -1, +3. So if we find that on our diagram, that's going to be about right there. All right, first part done. We have plot our center. Next, we want to determine how long our radius is. So here in our problem, we have our 4 represents the radius part of our equation. So we have, that is our x squared. So we have x squared is 4. So if we just want to find our radius, or not x squared, r squared, excuse me. So we have our r squared is 4. So in order to find our r, we can square root that number. So if we square root this side, that'll give us r. If we square root this side, that'll give us our number. So the square root of 4 is going to be, oh, wrong green, is going to be 2, because the square root of 4 is 2. So that means that our radius is 2 units long. All right, so we're going to use that radius to plot our 4 points. So basically, we're going to plot a point 2 units above, below, left, and right. So if we do that, we have 2 units above, 2 units below, 2 units left, and 2 units right. We've plot our 4 points. So kind of like how we did at the very beginning here, just in the opposite way. So finding the radius from the graph is, we have the radius in all 4 directions, giving us 4 points on our circle. We're doing the same thing here, just in the opposite direction. So we've plot our 4 points here, and now we just need to lightly sketch our circle. So if we do that, it doesn't need to be perfect. now we have our circle is graphed. And we have our radius represented right there as 2 units. All right, so this next one I do want you to try on your own, so pause the video and follow our 4 steps from our last problem. All right, so let's take a look at graphing this equation. So first thing we're going to need is our center and to be able to plot that. So our center is our HK. So we have our H is attached to our X, and we have -3, so that means that our H is going to be +3, and our K is attached to our Y, and so we have our K value is, since it's +4, our K value is going to be -4. So we have the point 3, -4 for our center. All right. So let's plot that point. So we have +3 to the right and -4 below. So we have our center is down here. All right, so let's take a look at our radius next. So we have our r squared is 9. So we have r squared is equal to 9. So if we square root both sides, that means our r value, or our radius, is going to be 3. So when we are plotting in 3 directions, or in our 4 directions, we're going to go up, down, left, and right 3. So we're going to go up 3, down 3, left 3, and right 3 are our different points. All right, and then lastly, what we want to do is we want to sketch our circle. So we're just going to connect our points on the outside to make our circle. Again, it doesn't have to be perfect. The main things I'm going to be looking for are that center and those points and the fact that you sketched it. So do make sure that you actually sketch the circle on there. All right, so that concludes our unit on graphing circles. So make sure that, and this is our last unit of chapter 10. So make sure that you study up for your test that will be soon, but I will be posting a review for you to look over to be prepared for your test. All right, I will see you next time.